to True Projects. In this video, we are going to explain about the project, which is tongue color classification in TCM with noisy labels via confident learning assisted knowledge distillation. Introduction of the project. The project focuses on the ancient Chinese healing system of traditional Chinese medicine, specifically on tongue diagnosis, which is a crucial component of TCM diagnosis. The tongue attributes including color, coating, thickness, texture, humidity, and the shape play a fundamental role in TCM diagnosis. The primary goal of the project is to classify the color of the tongue, which is one of the most important diagnostic attributes in TCM. The color categories include light red, dark red, and purple. An accurate classification of tongue color is essential for diagnosis. The project faces challenges such as noisy labels in annotated samples, which result from the individual experience of TCM experts, and ambiguous boundaries among tongue color categories. Additionally, there is a scarcity of labeled samples due to the time-consuming and expensive data collection and annotation process. To address these challenges, the project leverages deep neural networks but recognizes the risk of overfitting on noisy labels. To mitigate this issue, the project draws inspiration from the concept of knowledge distillation, where a teacher network transfers its knowledge to a student network, and we propose confident learning assisted knowledge distillation framework. The project's contribution including the development of the CLA-KD framework, which incorporates confidential learning, which is CL, to correct noisy labels and enhance the student network's training. Objective of the project. The primary objective is to create a framework called CLA-KD that assists in tongue color classification for TCM, particularly focusing on addressing the challenge of noisy labels in the dataset. The project aims to use a teacher network within the CLA-KD framework to perform confident learning, which involves identifying and rectifying noisy labels while facilitating knowledge transfer to a student network. The objective is to design an ensemble teacher network, which is ECA2 ResNet 80, to address the unreliability and instability issues typically associated with training teacher networks due to limited data samples. The project seeks to evaluate the performance of CLA-KD framework on the established datasets to assess its effectiveness in real-world scenarios. The aim is to achieve superior classification accuracy, improved model robustness, and reduce network model complexity with the CLA-KD framework. The final objective is to demonstrate the effectiveness of proposed CLA-KD framework through experimental results and comparisons with other existing methods, showcasing its advantages in TCM tongue color classification. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So the first step is importing the packages. This module involves importing necessary libraries and packages. We have imported Seaborn and Matplotlib for data visualization, NumPy for numerical operation, Pandas for data manipulation, Scikit-learn for machine learning, TensorFlow for deep learning, and OpenCV for image processing. The next step is exploring the dataset. In this module, we explore the dataset to gain insights into its structure and contents. This includes loading the dataset, examining its features, checking for missing data, and performing initial data analysis. The next step is image processing. This module focuses on pre-processing image data. Image pre-processing involves tasks like resizing, normalization, and data augmentation to prepare the images for training deep learning models. The next step is visualization using Seaborn and Matplotlib. Data visualization using Seaborn and Matplotlib helps to create informative charts, graphs, and plots to understand the dataset's characteristics, relationships, and patterns. Visualization aids in data exploration. The next step is splitting dataset into training set and a testing set. Data splitting involves dividing the dataset into training and testing subsets to assess the model's performance. The training set is used to train deep learning model, and the testing set is used to evaluate its accuracy and generalization. The next step is building the model. In this module, we define the architecture of deep learning model, and they are VGG16 and ResNet 18. The next step is training the model. This module involves feeding the training data into the deep learning model to optimize its parameters. The model learns from the data to make predictions. Coming to the next step, which is Flask framework with SQLite for sign up and sign in. Here we set up a web application using the Flask framework with an SQLite database for user registration, which is sign up, and authentication, which is sign in. This enables user to interact with the model through a web interface. The next module is user gives input. Here, user provides the input through the web interface, which are images. The next step is the given input is pre-processed. Input provided by the users is pre-processed to ensure it aligns with the model's requirements. The next step is the trained model is used for predicting the result. The pre-processed input is fed into the trained deep learning model, and the model makes predictions or decisions based on the input. For image-based projects, this involves classification or object detection. The next step is final outcome is displayed. The results or the predictions generated by the model are presented to the user through the web interface, completing the user interaction cycle. The algorithms which are used in this project are VGG16. It is a popular convolutional neural network architecture known for its strong performance in image classification tasks. It is characterized by its deep architecture using 16 weight layers. In this project, VGG16 have been selected for its ability to handle image data, which is often a key component in medical image analysis, including TCM tongue diagnosis. Here we use this algorithm to compare VGG16 with the ECA2 ResNet 18, which is the proposed algorithm. Coming to the proposed algorithm, which is ECA2 ResNet 18. ECA2 ResNet 18 is a customized neural network architecture designed for this specific project. It incorporates various components including E, which is activation function, and the CA is the attention model for feature optimization. ResNet 18 is a variant of residual neural network. Architecture is chosen for the project due to several key advantages. Its moderate depth strikes a balance between model complexity and efficiency, making computationally practical. Residual connections, a distinctive feature of ResNet architecture, helps mitigating the vanishing gradient problem and enables the effective training of deep networks, which is particularly valuable when dealing with the noisy data. ResNet 18 proves performance in image classification tasks, contributing to the robustness and generalization crucial for handling inconsistent and incorrect labels in the project. Additionally, the availability of pre-trained ResNet 18 model facilitates the model development process, allowing for efficient transfer learning and saving valuable time and resources. As an extension, we applied hybrid model to produce a more robust and accurate result, and it is used for final prediction. And we built frontend using Flask framework for user testing with user authentication. So here we have the comparison graphs of the project. This is the accuracy score comparison graph. It is a metric used to measure the overall correctness of a classification model. It is defined as the ratio of correctly predicted instances to the total number of instances in the dataset. Here on the x-axis we have accuracy score for each algorithm, and on y-axis we have algorithm names. Coming to precision score, it is a metric that quantifies the accuracy of positive predictions made by the model. It is defined as the ratio of true positive predictions to the total number of positive predictions. Here on x-axis we have precision score for all algorithms, and on y-axis we have algorithm names. Coming to recall score comparison graph, recall is also known as sensitivity or true positive rate, and it measures the model's ability to correctly identify all relevant instances in the dataset. It is defined as the ratio of true positive predictions to the total number of actual positive instances. Here on the x-axis we have recall score for each algorithm, and on y-axis we have algorithm names. Coming to F-score, which is F1 score, it is a metric that combines both precision and recall into a single value, providing balance between them. It is the harmonic mean of precision and recall, and it is particularly useful when we want to strike a balance between minimizing false positives and false negatives. Here on x-axis we can see that F1 score for each algorithm, and on y-axis we can see all algorithm names. Among all the algorithms except existing VGG16, hybrid extension model and proposed ECA2 ResNet 18 model is performing well. To execute the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. Here we have the dataset, and this dataset is used to train the models. And this is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. Here we have the model files. These two are the model files. These files contain the algorithm information which will be loaded into the project code during runtime. Here we have notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. This is the signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. And now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and click on enter. With this, current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. Here we need to type the command which is python space app.py and click on enter. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost. This is the localhost and the port, unless configured differently. Now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. So I'm copying the link now. Here we need to paste the link and then click on enter. So here we can see the web page of the project is displayed in the browser, and this web page is built by using the Flask framework. So here we can see a register link. First we need to click on it. And here we need to enter all the registration details if we are registering newly. I've already registered and I have an account in it, so we'll directly click on sign in. Here we need to give our credentials, which are the username and the password to log in. So I'm giving in my username and the password, and now we need to click on sign in. We have signed in successfully. Here we can see a choose file button. We need to click on it to upload the tongue images. So I'm clicking on the choose file button to upload the images. I'm selecting the first image, and now we need to click on open. The image has been loaded. Now we need to click on upload to predict. So here it is predicted that in the red color, the tongue belongs to dark red. Now we will upload one more image. Now we will select the second image and click on open. Here we can see that the tongue belongs to light red. Now we will upload one more tongue image and see what will be predicted. Now we will select the fifth image and click on open. Here we can see that the tongue belongs to purple color. Now we will upload one more image. We will upload the 8th image and click on open. Here we can see that the tongue belongs to red color. In this way, we can upload the tongue images to the system, and then the system will predict the tongue belongs to which type of color. Conclusion of the project. The CLA-KD framework presented in this project effectively tackles the intricate challenge of tongue color classification in traditional Chinese medicine, despite of the presence of noisy labels in the dataset. With CLA-KD framework, a teacher network plays a pivotal role in performing confident training, cleansing and rectifying noisy labels, and facilitating the transfer of valuable knowledge to a student network, ensuring accurate classification. To enhance the reliability and stability of the classification process, an ensemble teacher network named ECA2 ResNet 18 is thoughtfully designed. This network integrates the channel attention mechanism and the activate or not activation function, optimizing the model architecture. Comprehensive experimentation carried out on the dataset, which is tongue dataset, underscores the remarkable capabilities of CLAKD, showcasing its ability to achieve not only superior classification accuracy but also impressive model robustness and reduced network complexity. Moreover, the proposed CLAKD framework effectively identifies and rectifies inconsistencies in the dataset, leading to substantial enhancements in classification accuracy. This invaluable contribution bolsters its potential in TCM diagnosis and applications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.